Hi and welcome. This time around we have a quick project from the people that I work for, the welding company. These are welding fixtures for a seam welding machine. So if you imagine each one of these is a mandrel and pieces of metal get folded around, well, they're already pre-folded, and you squeeze them together, joining right at the center of the slot here. And then a laser welder comes down and welds the seam of the package together. So that's what these are for, and you can see that some of these have taken some significant damage from overshooting the laser. All of these ended like a 1/4 inch before the end. You notice they overshot and just basically ate holes right through. I'm tempted to try and weld one of these things closed, but I don't know if my welding skills are good enough to do this, but I might try it, see if I can weld one of these things, you know, completely fill it up and then recut it again, because that may help out. It really bugs me. And then they want me to deck off the top of these because there's weld splatter and cuts in it that make it so that the parts don't lie flat. They could just stone them with some precision ground flat stones, but they don't have any. So maybe I'll ask them if they want me to make them some at some point, because then they can just stone this. With aluminum, it's kind of a little bit of a pain because it loads up the precision ground flat stones. But there's a really cool trick that I learned from one of the other YouTubers, which is if you take a piece of cardboard, like this and you spray WD-40 on it and then rub the precision ground flatstone on the cardboard WD-40, it'll clean it right up. I'm not sure why it works so well, but it really does. So that's kind of interesting. Anyways, so let's see where we can get with this. What I might try and first is just clean one of these up with some acetone in the slot and see if I can weld it. And if I can, then maybe I'll weld them all and then recut the slot, because that'll improve it. So this slot here is for backing gas. So argon gets fed from the tip over here, and then the bottom is flush against a flat piece of metal. So the gas goes down this slot here, up through this hole here, and then equally out in both directions on the slot. Now, it would normally flow pretty well into the whole slot, but with an opening on one end, it's mostly going to go this direction. It's not going to cover here as well. So that's a bit of a problem. So they probably want these filled up. So we're going to try the welding thing and see how that works. All right, so my welding skills are pretty poor, but after I did the first one and filled it in, I decided I was going to do all the others, because the first thing they wanted me to do is deck each one of these off and clean up all the little potholes and everything so that the work pieces would sit flat. And again, as I mentioned earlier, precision ground flat stone might solve their problem. But in the meantime, I think what I'll do is I'm going to deck these first, all of them, make them the same thickness so that the top's clean, and I'll get rid of my weld. And then we're going to re-slot all of these. And once we're done, they should have something much better than when we started last time. All I did was recut the slots because they fill up with debris and whatnot, as you did see. When I was welding these, I would run along the slot on each one with the TIG torch without any filler, moving pretty quickly just to clean out a lot of debris right off the bat, and that sort of spits debris out. And that would also preheat the material, and then I'd come back and fill on the way back. Still, as you can see, there's some black spots here, besides me touching down with the torch because my TIG skills are pretty mediocre. My big problem was dirt in the slot, and it was very hard to clean out. Now, if I really want to do this right, I would have used an end mill and cut out the slots even bigger and cleaned them all up so it was nice and clean, and maybe used a chamfer bit to do it and then filled in with the TIG after that, and then I'd have something as good as new. Instead, it's going to work just fine. There's no strength issues here. Before I loaded in my facing cutter, I did find the middle between both sides and this end point, and I'm using my stop here to be able to find the part again. And I'm going to go about 3 thousandths deep for a cut. Hopefully that'll clean up the whole surface. That's going to be my new Z-knot. Locked everything off. Kind of looks like we've got a shitty insert on this guy here. One of these. So I'm going to rotate the insert so I get a cleaner finish, because this isn't great. Although it could be the filler rod too that's kind of smearing over this whole top section. We're also going to try a little bit of lube, since that may be part of it. Let's just see how that goes. Oh yeah. Changing the inserts definitely improved it. That's the first one done. I'm going to pull the part out, put the next one in. I'm just going to face back and forth on each one, and then we'll come back and slot them all after. And then I got to re-drill the hole for the argon to get through. The weld material is kind of soft, and it looks like it's smearing, even though with a little lube. Looks like I don't have a perfect solution there. And I might not have to go quite as deep next time, but we're also going to try that. But you can see that the cut cleaned up after I was out of the weld. Next up, I'm going to do the slotting. I have a 2-flute zircon nitride coated end mill, and we're supposed to go 100 thousandths deep for 6 1/8, a 1/4 inch in, which is where I'm at. So we're going to turn this guy on. We're going to crank up the speed, and we're going to plunge first. Total depth is 100 thousandths. And I think we're good to go. Just go for 6 1/8 inches. Move on to the next one. Got some chip packing going on. True to form, broke the damn end mill. I thought I was doing pretty darn well, but I think chip packing hosed me. And I don't have a lot of these zircon nitride coated ones. Damn. Looks like I can't do more than 50 thousandths a pass. And I have to actively clear chips. That was a completed pass. I even increased the RPM more. I think you can probably go as fast as this mill will go. I'm currently at 3,600 RPM. I might try 4,000 next pass. You still have burrs on this. What I do is I take this over to a surface plate. Well, it's a flat plate with sanding paper on it. And I just run the sandpaper across it, and it removes the burrs pretty nicely. Then I take Scotch-Brite to clean it up. There you go. You can see some of the burrs on there. So I take those off with sandpaper. Then I run another piece of sandpaper down the middle. Last step was take these guys and drill the hole, 3/32 hole back through. And I did it with a hand drill because it isn't super precision or anything like that. So one of them was a little bit off there. Most of them followed the existing hole. This one got filled in almost all the way. Bottom line is this is much improved over what it was. I think the customer will be happy, and it should last them another year or so. And then ultimately, maybe we'll have to make all new ones of these, because you can tell where the laser misses. And on the bottom, I'm not sure how they do that, but anyways, they do. So that's it for this part. This project is complete.